Hi everyone, today we're going to talk about graphing absolute value equations. When we talked about our transformations in general, we did not talk about how you would apply them to an actual graph. We very basically looked at like shifting and moving physically the graph, but today we need to start the conversation of how would we do that to the parent table. The parent tables are what is going to help us the most when graphing different parent functions throughout our units. So we know from previous that when we subtract inside the parentheses, we're moving right C. But what we're adding to it today is that anytime you make a horizontal change, you're changing the X values. So I'm going to write that here to remind us we change the X values or the input column. So if we're moving right C, we're going to add C to the X values. Now, every horizontal change will change the X values, so this entire column will talk about our X values. If we're moving left C, we're subtracting C from the X values. When we talked about the horizontal stretch and the horizontal shrink, we already accounted for the fact that we're talking about the reciprocal because it's inside. So when you figure out what that reciprocal is, that's actually what you want to use in your table. So when we're horizontally stretching by the reciprocal 1 over C, we want to multiply the X values by 1 over C. And because we've already accounted for the reciprocal, a shrink would actually be the same thing, multiplying the X values by 1 over C. To reflect over the Y-axis, we're actually multiplying the X values by -1. So as you can see here, any horizontal change is going to affect the input column of the table. When we talk about vertical changes, these changes are actually going to affect your Y values. Therefore, when you're reflecting over the x-axis, you're multiplying the y values by -1. When we work with our vertical transformations, our outside transformations, the numbers are what they are. We don't make any changes to them. So the transformations are the ones that we would expect. In order to vertically shrink by C, we're going to multiply our y values by C. And we would actually do the same thing for a vertical stretch. Our C value would just be different. If we want to move up C units, we would add C to our Y values. And if we want to go down C units, we would subtract C from our Y values. As we start graphing, I would have these two tables, this table and this table, out on your desk as you work. So make sure you wrote them down in your notebook. Having the math operations to do to the table really does help us out when we're trying to graph from a parent function. It is important for us to describe transformations in a certain way, especially when we're trying to graph an equation. So here is a guideline for how to describe your transformations. If they are on the same step, then the order of them doesn't necessarily matter. I tell my students it's much easier to just go in order of your chart. You want to describe the transformations from the horizontal chart first from top to bottom, and then the vertical chart from top to bottom. But here are some good guidelines for it. We want to talk about our horizontal shifts left or right first. Then we want to talk about our horizontal shrinks, stretches, or reflections. Then we can move to the outside to the vertical. We could talk about our stretches, shrinks, or reflections. The absolute last thing you want to do anytime you're describing or graphing is shift a graph up or down. Today, we want to specifically discuss the absolute value function. So our parent function for the absolute value is the equation f of x, or y, equals the absolute value of x, the most basic form of that equation. If we were to test a few points to get the center, let's say x equals -2, -1, 0, 1, 2, we would end up with a parent graph that has a V in its shape. The domain of our parent absolute value is -infinity to infinity. The nice thing about absolute value functions is all of their domains, no matter the transformations, will be -infinity to infinity. Our range is from 0 to infinity. That might change depending on what transformations you're working with on your graph. When we talked about our transformations, we talked about our grouping symbols, our parentheses. We were talking about inside parentheses or outside parentheses. In the absolute value function, the absolute value bars act as our grouping symbols. So when we're talking about inside, we're talking about inside the absolute value bars. When we're talking about outside, we're talking about outside the absolute value bars. We just have straight absolute value bars instead of parentheses. When we describe transformations, we really want to make sure we're paying attention to these 4 steps here. Talking about anything horizontal first and then vertical. Otherwise, you're describing a different graph. So the first transformation I see is inside. We're subtracting 1. That would move us right 1 unit. We're multiplying by 3 to x, so we would actually be dealing with a reciprocal of 1/3. I like to consider the reciprocal first before I decide if it's a stretch or a shrink, because it's a lot easier for me when I know the actual number I'm working with. I know it's horizontal because it's inside. The actual number is 1/3. That's getting smaller, so this must be a horizontal shrink by 1/3. There's a transformation on the outside here. A negative on the outside is a reflection about the x-axis. If you write flip, we will not give you credit for that because flip is not a math word. And then our last transformation is over here. We're adding 5 on the outside, telling us to move up 5. If you are able to describe the transformations on the graph, then it just makes your graphing process much easier. That's why we put so much focus on describing the transformations and talking about what they are in the equation before we actually move to the graph. All right, so let's use a similar thinking to work through number 2. We're adding 3 on the inside, which tells us that that is a shift left 3. We have plain old x, so there's actually no more transformations on the inside. We have a 1/2 being multiplied on the outside, indicating a vertical shrink because 1/2 is smaller by 1/2. And then we're subtracting 12 on the outside here, indicating a shift down 12. Talking about a shift up or down really is always your last step. So when we are graphing absolute value equations, it's very important for us to describe transformations and use those transformations on the parent table. We're going to perform the transformations using the directions we talked about at the beginning of this video, like the add c to the x values or subtract c from the y values. And that allows us to put guideline points on the graph. We know that the shape of an absolute value function is a V because of its parent. So if we could get points on the graph, we just connect them, making a V. We've graphed. The last thing you always want to do when you graph is state the domain and range. So we will start by describing our transformations. The first thing we see here is a subtraction on the inside. So that first step is telling us that we are moving right 1. We then have a -2 in front of the x, and we have to be careful there. We have to remember that the 2 is its own transformation and the negative is its own transformation. So there are actually 2 things happening there. I like to talk about the number before I work with the negative, but they do run on the same step here when we're talking about how to describe. So it really wouldn't matter if you talked about the reflection or the shrink first because they're on the same line. It's really personal preference at that point. But I'm going to talk about the shrink. I know it's a shrink because the number I'm working with is 1/2. 1/2 is smaller, so horizontal shrink by 1/2. The negative, like we talked about, was a reflection, and it's a reflection about the y-axis because it's on the inside. And then last but not least is our subtraction of 3 on the outside here, telling us to move down 4. So these are our directions to graphing. Our starting point when we have absolute value bars is our parent, that table that we put earlier in our notes, where we tested -2, -1, 0, 1, 2, and got out 2, 1, 0, 1, 2, our middle points of that absolute value. In order to move right, I have to change the X column of this chart. So I'm going to copy everything else. I don't want to confuse myself, and copy everything I'm not using. To move right, I have to add 1 to the X values. So instead of writing the X column from the parent, I'm going to add 1 to every one of those values and create a new set of X values for the function I'm working with. Now, when I adjust to shrink by 1/2, I'm going to change my new table, the most recent table. In order to shrink by 1/2, I know I have to multiply the X values by 1/2. So I'm actually going to copy everything I'm not changing over before I multiply. Multiply everything by 1/2, that's negative 1/2. Decimals are a little bit easier for me to work with when I'm graphing. So I multiply all of those X values by 1/2, ending up with that new X column. Now when I change, I'm changing my most recent, or the one that has some red written on it. When I reflect about the y-axis, I need to multiply the X values by a negative. So I'm going to copy everything except for my X values from my most recent chart, and I'm going to multiply all of my X values by a -1. Now, you don't multiply 0 by a negative, like you wouldn't write -0. It just doesn't make sense. 0 is kind of special. And last but not least, we're moving down 4 by subtracting 4 from the y values this time. So this time I'm going to copy my most recent X values and subtract 4 from all of my y's here. So in order to go down 4, I'm going to subtract 4 from all of my y values. Once you've performed your last transformation, this is the table that you're going to put on your graph. So the coordinate points I'm putting on my graph are 1/2 -2, 0, 3, -1, -3, and -1.5, -2. We then connect those to make our absolute value v. Our last step is stating the domain and range. We know the domain is -infinity to infinity for all of our values. We know the domain is -infinity to infinity for all of our absolute value graphs. And the range here would be from -4 to infinity. The key with graphing is knowing your transformations and also knowing which parent to start with. Now, we are only working with absolute value right now, so we're going to be starting with the parent I have written on this side in black every single time to practice this skill in this section.